Good day to one and all. I am Ms. Revati T, Assistant Professor, Department of Chemistry, Auxilium College, Vellore. Today we are going to learn about the concept of equivalent weight. When any new chemical compound is synthesized in the laboratory or isolated from any natural source, as a chemist, our first role is to determine its elemental composition, its empirical formula, molecular weight, equivalent weight, etc. Hence, this lecture focuses on how to calculate equivalent weight of any element or compound. These are the learning outcomes. At the end of this class, you shall be able to define equivalent weight, calculate equivalent weight of an element, acid, base, salt, oxidizing and reducing agent. In general, equivalent weight is a unitless quantity which is a ratio of molecular weight and valence factor. Valence factor changes according to type of reaction. Equivalent weight is usually denoted by E. First, let's learn how to determine equivalent weight of an element. From the general formula, as said before, which is equal to molecular weight divided by valence factor, here equivalent weight of an element will be equal to atomic weight divided by the valency. Here the valence factor is valency. I hope you all know what is valency. Valency is the combining capacity of an atom. If you are wondering how to determine net valency, you can find it simply from the periodic table. Let me show you how to find it. In the periodic table, the group 1A elements or alkali metals lose one electron and form +1 ions. The group 2A elements lose 2 electrons and form +2 ions. Group 3A elements or the boron family elements lose 3 electrons and form +3 ions. Group 4A elements or carbon family elements, they either lose 4 electrons or gain 4 electrons. Hence, they form +4 or -4 ions. Group 5A elements or nitrogen family elements are being electronegative, gain 3 electrons and form -3 ions. Group 6A or oxygen family elements gains 2 electrons and form -2 ions. Group 7A or halogens gain 1 electron and form -1 ions. Noble gases does not gain or lose electrons, hence they do not carry any charge. So finally, we can remember the valency of group 1A and group 7A. Valency is 1. Group 2A and group 6A valency is 2. Group 3A and group 5A valency is 3. Group 4A is 4 and the final noble gases has the valency 0. Coming back to the determining equivalent weight of an element. So here equivalent weight of an element is equal to atomic weight divided by valency. In calcium, the atomic weight of calcium is 40.08 and the valency is 2 since it belongs to group 2A element. Substituting the values in the above formula, we get equivalent weight of calcium which is equal to 40.08 by 2 which will be equal to 20.04. Now let's learn how to calculate equivalent weight of acid. In the general formula, we need to substitute the valence factor by basicity of the acid here. What is basicity of the acid? Basicity of the acid is equal to number of replaceable H plus ions present in the formula. We can simply determine the number of H plus ions in the formula. Now, let's take the example of sulfuric acid. Here, the molecular weight of sulfuric acid is 98, which is determined by the addition of atomic weight of individual atom present in the compound. Here, the number of replaceable H plus ions is 2. Hence, equivalent weight of sulfuric acid is equal to molecular weight 98 divided by basicity of the acid or the number of H plus ion, which is equal to 2. Hence, the equivalent weight of sulfuric acid is calculated to be 49. Using the same formula, you can calculate equivalent weight of any acid. Here, we have taken phosphoric acid. Here, the number of replaceable H plus ion is 3 and the molecular weight is 97.97. Hence, equivalent weight is 97.97 divided by 3, which is equal to 32.66. The other example is HCl, which has only one replaceable H plus ions and the molecular weight is 36. Hence, equivalent weight of HCl will be equal to 36 by 1, which is equal to 36. Next, we are going to see how to calculate equivalent weight of base. Here, in the general formula, we need to substitute valence factor by acidity of the base or the number of OH minus ions. Acidity of the base is equal to number of replaceable OH minus ions per unit formula. We can simply calculate the number of OH minus ions in the formula. Now, let's take the example NH4OH, for which molecular weight is 35 and the number of OH minus ions or the acidity is only 1. Hence, equivalent weight of NH4OH is 35 by 1, which is equal to 35. Using the same formula, we can calculate equivalent weight of any base. Here, calcium hydroxide is taken as an example. Here, molecular weight of calcium hydroxide is 74 and the number of OH minus ion is 2. Hence, equivalent weight is found to be 37. Let's calculate equivalent weight of salt. In any neutral compound like salt, the total positive charge and the total negative charge remain same in magnitude. Hence, the magnitude of total positive charge or the total negative charge is considered as the valence factor to calculate the equivalent weight of salt. For example, in NaCl, the total positive charge or the charge of the cation is 1. Hence, equivalent weight of NaCl will be equal to molecular weight 58.5 divided by charge of Na plus is 1, which is equal to 58.5. Here, for magnesium sulfate, for a change, let's take the charge of the anion. So, molecular weight is 120 divided by charge of the anion is 2, which is similar to the charge of the cation also. So, on substituting, you get the answer 60 for equivalent weight of magnesium sulfate. Now, let's see how to calculate equivalent weight of oxidizing and reducing agent. First of all, we should know what is oxidizing and reducing agent. Oxidizing agent oxidizes others and reduces itself by gaining electrons. As you can see here, KMnO4 is an oxidizing agent which gains electrons, and reducing agent reduces others and oxidizes itself by losing electrons. You can see ferrous sulfate is the reducing agent which loses electrons here. So, the formula to calculate equivalent weight of oxidizing and reducing agent is equal to molecular weight of oxidizing or reducing agent divided by number of electrons transferred in redox reaction, that is number of electrons gained in case of oxidizing agent and number of electrons lost in case of reducing agent. First, let's take the example of oxidizing agent KMnO4. In this reaction, in acidic medium C8H+, in acidic medium, the electrons are gained to convert Mn7+ to Mn2+. So, 5 electrons are gained in this reaction. Hence, equivalent weight of KMnO4 is equal to 158, which is the molecular weight of KMnO4, divided by 5, which is the number of electron gained. Therefore, equivalent weight of KMnO4 is equal to 31.6. However, the number of electrons gained or lost by an atom may vary in different medium. As KMnO4 gains 5 electrons in acidic medium, it gains only 3 electrons in basic and neutral medium. Therefore, the number of electrons gained here is only 3. Equivalent weight of KMnO4 will be equal to 158 divided by 3 in basic and neutral medium, which is equal to 52.66. Now, as I already said, for reducing agent, we need to consider the number of electrons lost. So, for ferrous sulfate acting as reducing agent, the number of electron lost is only 1. The equivalent weight of ferrous sulfate will be equal to 151.8 divided by 1, which is equal to 151.8. We have come to end of this lecture. The summary is, all the above discussed expressions are widely used in chemistry lab for preparing various reagents and diluting the stock solutions. Equivalent weight of the solution may vary with the variation of its valence and the type of reaction it undergoes. Now it's time to test your understanding about the topic. First is a simple question, which is how to calculate the equivalent weight of nitric acid. Second, how will you calculate the equivalent weight of ammonium nitrate? Ammonium nitrate is found to be one of the key factors in Beirut blast in Lebanon. Third question is, lead chromate is nowadays used to adulterate turmeric. So find the equivalent weight of lead chromate. These are my references. You can use this for further understanding. Thank you.